Hi, in this lesson, I'm going to talk about trigonometry, specifically the sides part of it. And when it's all said and done, hopefully you're going to be able to calculate the value of the trig ratios, and you're going to be able to find the length of a missing side in a right triangle. So to get going, if I want to look at trigonometry, I found out that it came from the Greek roots, trigon, meaning triangle, and ometry, meaning measure. So when you put it all together, you're looking at measures of triangles, basically. But I have a little definition here also of trigonometry. It's just the study of those properties of triangles, which I guess goes back to our Greek roots. I have a little acronym here, but the thing that I need you to remember when we're talking about trigonometry is it's those ratios. That's the big thing, the ratio of the sides of a triangle. Keep that in mind. So every time you think of trigonometry, you're thinking of ratios of sides of right triangles. Now, an acronym that's helped me out a lot to remember the trig functions is this SOHCAHTOA. And what that is it's just S stands for sine, which is one of our trig ratios. Now sine is the ratio of the opposite side of our triangle over the hypotenuse of our triangle. Maybe I should scroll this down a little bit more so you can see it all. There we go. So that's the SO part, deals with sine, opposite over hypotenuse. The C deals with cosine, another one of our trig functions. Now cosine is the ratio of the adjacent side over the hypotenuse. And our last one is tangent, so the T, and tangent is the ratio of the opposite side over the adjacent side. Now notice, in each one of them I said, and for sine I said opposite over hypotenuse. Cosine I said adjacent over hypotenuse, and tangent I said opposite over adjacent. So again, there's that ratio when I'm turning it into a fraction by saying the word over. Now here's what I want us to look at. I want to look at us figuring out the sine ratio here in terms of this triangle. It has no numbers, it has no angles, but we're just going to look at it in terms of variables. So if I'm looking at the sine of A, I want to start here at angle A. That's what it's telling us. Now remember, sine is the ratio of the opposite side over the adjacent side. So I can look at this as the opposite side from A, I have to go to the opposite side of the triangle. Well, that's side BC. Over the hypotenuse, well, the hypotenuse, that's always the same. That's never going to change in a right triangle. It's the longest side. It's the one that's opposite the right angle. So in this one, that's going to be side AC. So my sine ratio for angle A is side BC over side AC. Now, if I want to do the sine of C, now I have to get rid of this stuff. Now I want to go to angle C. And then I want to go, well, it's still opposite over hypotenuse, but now the opposite side from angle C is side AB. So the length of side AB over the hypotenuse again is side AC. And there's our ratio, our two ratios for sine, depending on which angle we went from. I want to do the same thing with cosine. Well, cosine of angle A, I'm going to go to angle A, and now we have to think back of, well, what ratio is cosine? Cosine is the adjacent side. So now I'm going to go to the adjacent side, the one that's next to angle A, but not the hypotenuse. So the side next to angle A, that's not the hypotenuse, is this side, which is side AB. So we have the length of side AB over, and cosine is adjacent over hypotenuse. Hypotenuse is side AC. Now, if I wanted to calculate the cosine from angle C, well, I'm going to come up here. I'm going to do the same thing, but now remember, it's still adjacent. So which side's adjacent to angle C, but not the hypotenuse? This one right here. And that's side BC. And then cosine is over the hypotenuse, which is side AC. My next one is tangent. Remember, tangent is the ratio of the opposite side over the adjacent side. So now I'm going to go from angle A so that I can figure out the tangent of A. And then I'm going to go, well, opposite angle A is side BC now the adjacent side, that's the one that's next to it, but not the hypotenuse. It's right here. So that'd be side AB. That's how I'd calculate the tangent of angle A. Now, if I wanted the tangent of angle C, I'm going to get rid of this and do the same kind of thing. Again, I'm going to do the adjacent side, but this time the adjacent side is right here. So that's side BC over the opposite side, which is here, which is side AB. And there you go. Did I do that? Oh, I did that wrong. I apologize. First, I need to do the opposite, because tangent, remember, is opposite over adjacent, SOHCAHTOA. TOA. So I have this mixed up. Let's fix that before we have everybody confused. So my opposite side would be this one first, and that's side AB. Over the adjacent side is side BC. There we go. That looks a lot better. Sorry about that. I hope I didn't confuse too many. Now, what you'll notice, when you take the tangent of one angle and the tangent of the other angle, they're reciprocals of each other. Okay? Just something to recognize and notice there. Now, I'm going to do the exact same thing here, but this time I put numbers on there. So I'm going to just start with angle A, and we're going to run through and find the sine, cosine, and tangent, or not A, X, angle X right here. Okay? So if I want the sine of angle X, remember I have to do opposite over hypotenuse. So if the opposite side from angle X is 4, the hypotenuse is 5. If I went here to cosine, cosine is adjacent over hypotenuse. Well, the adjacent side is 3, and the hypotenuse is 5. And then if I went to the tangent of angle X, tangent is opposite. Make sure I do this right this time. Opposite side is 4 over the adjacent side, which is 3. So the tangent of X is 4/3. Now let's do the same thing, but let's go from angle Z. We'll find the sine, cosine, and tangent of angle Z. So the sine of angle Z, remember sine is opposite, so which side's opposite angle Z? It's the 3. Over the hypotenuse, hypotenuse is still 5. Then we'll go to the cosine. Cosine is adjacent, so the side adjacent to angle Z that's not the hypotenuse is 4. And then over the hypotenuse, well, that's 5. And last but not least, we'll take the tangent again. Remember, tangent is opposite over adjacent. The side opposite angle Z is 3 units long. And the side adjacent to angle Z is 4 units long. And we have calculated the ratios of sine, cosine, and tangent depending on whether we're going from angle X or angle Z. And all those ratios we left as fractions. We could turn them all into decimals as well, but a lot of times the fractions will be just fine. Now, the next thing I want to do is I want to take a look at how we'd use our calculator. So I want to just simply calculate the sine of 30 degrees. This is where you're going to need your calculator. I have this TI-84 Plus Silver Edition on my computer, and you just have to make sure that your calculator is in the right mode, and it needs to be in degree mode. So if I need to check that, I can push the mode button on my calculator, and I'll notice down here, the third one, I have radian or degree. Mine is already in degree mode, which is good. If it's in radian mode, you're going to want to switch it to degree for everything that we're going to do. There are some situations where radians is the unit of measurement, and then you'd want it in radians, but I'll tell you, everything we're going to do, degrees. So if I want the sine of 30, I just have to push sine on my calculator. Comes up like that, and then I push 30, and I push enter. And I find out that the sine of 30 comes out to be 0.5. If I want the cosine of 60 degrees, I just push cosine, and then I push 60 degrees, and you'll find out that it's maybe, there we go, the same thing as the sine of 30 degrees, 0.5. And last but not least, I just put the tangent of 45. You could type anything you wanted in here and calculate it, but the tangent of a 45-degree angle is 1. And we have them. Now, here's my last problem that I have for us. In this one, I want us to calculate the lengths of missing sides in a right triangle. Now, you've gone through and you've calculated missing sides in a right triangle using the Pythagorean theorem before, where you had 2 sides and you had to calculate the third side. Well, notice here we're only given one side, and we have to try to find these other two. Now, we can't do them both at the same time, so we're only going to find one at a time. What I'm going to do is I'm going to find side R first. To do that, I'm going to look at the angle that I know. Now, not the 90-degree angle, one of the other two acute angles. Sometimes you know them both, sometimes it only gives you one of them. Now, yes, we could go through and we could figure out the measure of this angle, but we don't need to for this problem, so I'm not going to waste our time doing it. I'm going to look at the one angle that I have, which is the 12-degree angle, and then I'm going to look at this R, because I said I wanted to find R. So I need to find the side that's opposite the angle I know, and then I have to look at, well, which side do I know? I know the 15. Okay? So I ask myself these two questions right away. Which side am I looking for? And that turns out to be the opposite side. Which side do I know? That's the adjacent side from my 12-degree angle. And now I ask a third question. Well, which trig ratio deals with opposite and adjacent? And I think back and I go, oh, that's tangent. So I'm going to use tangent. And tangent of what? Well, it's always the angle that you were working from, which in this case was the 12-degree angle. So I have the tangent of 12 degrees. Think back to the previous slide. We could type that on our calculator and get a decimal approximation. I'm not going to yet, but I'm just going to leave that as tangent of 12. Now remember, tangent is equal to a ratio that we just said was opposite over adjacent. Well, now I write that ratio down. How long is my opposite side? I don't know. That's my variable R. How long is my adjacent side? That I do know. It's 15. And now I have this equation that I can solve. Now, I like to turn it into a proportion, so I would take this tangent of 12 and put it over 1, because that doesn't change the value. It just makes it look like the proportion that I like to solve. And I like to solve proportions by cross-multiplying. So I cross-multiply this way, and that works out really nice. That is just R. Now, when I cross-multiply this way, that's a little different story. This is where I go to the calculator. Now, think back to that previous slide. We've already learned how to calculate the tangent of 12 degrees. We just type it on our calculator. Then we need to multiply it by the 15. So I'm going to come back to my calculator. Maybe I'll slide it over here so we can see. I don't need any of that anymore. So I'm going to take, what I like to do is I like to start with the number, in this case, the 15, and then push times tangent 12. Now, the reason I like to do that is because then I'm less likely to make a mistake, because if I don't close that parenthesis, if I do it the other way, it causes problems. Here, if I forget to close my parenthesis, not a big deal. I can close it, and then I push enter. So I find out that R is 3.19. I'm going to go with the approximation. Now, I'm going to leave this up here because this is why I like to do the number first. Because if I were to start with the tangent 12, and then I have to multiply by the 15, right? But if I push times 15, my calculator's not going to know what I'm thinking. So when I do it like this, the calculator's first going to multiply the 12 and the 15 together, and then it's going to take tangent of that. So when I multiply it, I get the wrong answer. Now, you can fix that very easily by taking the tangent of 12, because that's what we want, close that parenthesis, because you want the tangent of 12 degrees, whatever that is, then multiply that by 15. Now we're still going to get the 3.19. So come back to this, and I'm going to put my 3.19. I don't have a label. I'm just going to put units on it. So there's R. Now I have to go back and figure out what C is. Now, some of you will look at this and go, well, if I already know that R is 3.19, I could just use the Pythagorean theorem to figure out what C is. And technically you could. I don't like to do that because, as you saw, this 3.19 is not the exact value. It was 3.188 something, something, something. And it just kept going on. So I like to go back and use exact numbers, so I'm going to use trig again. Now, this time, I have to ask myself those three questions that I did earlier. I'm still going to go to my 12-degree angle. And this time I look at it and I go, well, which side am I looking for? Since I'm looking for C this time, that's the hypotenuse. And which side do I know? Well, that's the 15, so from the 12-degree angle, that's the adjacent side. And then I ask myself that third question. Which trig ratio works with hypotenuse and adjacent. Cosine. So I'm going to use cosine. Cosine of what? Well, the angle that I was working from, the 12-degree angle. And then cosine is what ratio? Well, it's adjacent over hypotenuse. How long is the adjacent side? Oh, it's 15. How long is the hypotenuse? I don't know. That's my variable, c. And now I have this equation to solve. And like I said, I like to turn it into a proportion. So I'm going to put that over 1, and then I'm going to solve. Now when I do this, I get 15 that way when I cross multiply. And when I cross multiply this way, well, I get the cosine of 12 times c. Like this. Now, for some of us, that's a little confusing because we're not used to seeing it that way. But again, I look at this and go, remember, this cosine of 12 right here, that's just a number. We could type it on our calculator right now and turn it into that decimal. Okay? So it's like thinking of 15 equals 3c. I'd divide both sides by 3. But since it's the cosine of 12, I'm not going to divide both sides by 3. I'm going to divide both sides by the cosine of 12. Because now, those cosines of 12 divide out. All I'm left with is c on the right side. Well, I have to do the same thing over here, cosine of 12. And then I just go and grab my calculator, and I type it in. So it says 15 divided by the cosine of 12. We can close the parenthesis or not, it doesn't matter on this kind of calculator. I push enter, and I find out that my hypotenuse is 15.34. And again, I didn't have a label, so I'm going to call it units. So I found the length of my hypotenuse right there, and I found the length of one of the sides of my right, or one of the legs of my right triangle right there, using trigonometry. And that's going to conclude my lesson on trigonometry, where we found the value of the trig ratios and we found the length of missing sides.